product of complex number. So today we'll see on multiplication of two complex numbers. Okay, so let's see with example. Okay, if you are given two complex numbers, let's start with the general one. Alright, if you have two complex numbers, Z1, which is a plus bi, and Z2, which is c plus di, let's find the product of the two complex numbers, Z1 times Z2. Alright, so you can apply the same property as you apply real numbers, okay, binomials. Alright, so let's see this one. So you have here a plus bi into and c plus di. So you can use distributive property here. You can use distributive property, commutative property, associative property. It works for complex number as it works for real number. So let's multiply here. Let's distribute a here. Let's distribute a with c and a for d. Alright, so that gives us a times c is ac and a times d is ADI. Alright, so let's do the same thing for BI. So B times C is BCI, and B times D is plus B times D times I is I squared. Alright, this is maybe the difference from real number. So you can combine here AC, okay, plus, so you have in this case I is common, so AD plus BC. Alright, so plus, okay, so since I squared is the same as -1, so instead of let be BD times, instead of I squared, substitute -1. So this negatives change the positive one, so it goes to AC plus in the bracket AD plus BC times I minus BD. So combine like terms, so which means combine these two. So AC minus BD is plus, this is of course the real part, and the imaginary part become AD plus BCI. So this is the product of the two complex number Z1 and Z2. This is the same thing that as we do for real number situations. Let's see some example. Okay, so let's Z1 is equals to minus 2 minus 3i, and Z2 let it be is 4 plus the square root of negative, let it be 4. Okay, pause the video and try by yourself. Okay, so first we have to change this. We have to change this to almost a plus bi form. Okay, so this is the same as 4 plus this is -1 times 4. So the square root of 4 is 2. So this goes to 4 plus 2 and the square root of -1. This is because this is the same as -1 times -4. So the square root of -1 is I. So we're done. So let's multiply. -2 minus 3i times 4 plus 2i. So you can distribute here. Alright. So -2 times 4 is -8. So -2 times positive 2i is -4i. So do the same thing for -ci times 4 is -12i. So -3 times 2i is -6i squared. So -8 minus, so you have here 16i. So this I squared is the same as -1. -1 times -6 is positive 6. So when you combine these two, that's going to be -2 minus 16i. Okay, this is just easy. So let's check if -1 is a multiplicative inverse, or I mean multiplicative identity for complex number. You know that 1 is multiplicative identity for real number. When we say multiplicative identity, It's just like identity. In this case, you can consider as a mirror. If you put your hand in front of the mirror, you will see your hand. So if you multiply any real number a, okay, by 1, it gives you the number itself. Okay, any real number where a is an element of real number. You can also apply for a complex number. Okay, so let z is a plus bi. Okay, so you have here 1. Okay, so when you multiply z by 1, or this is just the same as z times, okay, 1 is 1 plus 0i. Okay, and then you have here z, which is a plus bi. So if you apply this one to 0i, and if you just apply this distributive property, so you will get the same thing. There you have a, and if you multiply this one 0, if you multiply this to plus bi, and finally when you multiply this, that goes to 0. So finally you come up with a plus bi, which is the original complex number. So we can say that 1 is an identity for multiplication of complex number as well.